Let's move on to the natural logarithmic function ln x is equal to 1 over x. It is valid for positive value of x because the argument of the logarithm should always be positive. Then, by considering the inverse operation, we will have the integral of 1 over x when x is positive. The integral is ln x plus c for indefinite integral. Then it raises a question of what if x is a negative value? Since we know 1 over x is also valid for x less than 0. And in order to answer this question, we will introduce a new function, which is ln absolute of x. And for this function, the derivative is equal to 1 over x. It is valid for all real numbers except 0. We can illustrate this one using a simple example. If we have negative 2, then we know ln negative 2, it is undefined. But if we consider the absolute of negative 2, which will become positive 2, then ln 2 is valid. Therefore, the main difference is the absolute of x. Then similarly, by considering the inverse operation of differentiation, we will have the integral of 1 over x, which is equal to ln absolute of x plus c. This formula is valid for all real numbers of x except 0. Now we are going to focus on these two formulas and try to show how we obtain them. We will start with the first formula. For function y equals ln x and x is positive. And then we are going to convert the relationship between x, y using the exponential form. We can change them to the power of e on both sides to get e to the power y equals e to the power ln x. E and the ln sign can be cancelled out. Then we will have x left, and to the right part we will have e to the power y. Then we are going to differentiate both sides with respect to x. On the left-hand side, e to the power y, it is a composite function, and we will differentiate the exponential function, and then in the function y with respect to x, then we will have dy over dx. And on the right part, we will have 1. After that, we keep the derivative sign dy over dx on the left-hand side and both sides divided by e to the power y. After that, by considering the relationship between y and x in the exponential form, we know e to the power y is equal to x. And put it back, we will have the result 1 over x. Y dashed is equal to 1 over x. It's how we obtain the first formula. On the second formula, here we are going to focus on the function y equals ln absolute of x. And we have to recall the modulus function. And this one is defined as when x is greater than or equal to 0. It's just itself. Now, when x is less than 0, the absolute of x is defined as its opposite. Therefore, when we try to show the process, first we can consider the case when x is positive. Then the function will be simplified to y equals ln x. We know the derivative of this function is equal to 1 over x directly. We will look at the case when x is negative. The function will be changed to ln negative x, because when x is a negative value, absolute x will become negative x. So when we deal with the derivative of this function, it is the composite function. The inner one is negative x, and the outer function is the natural log. Therefore, by using the chain rule, we can get the result in this way. Let u be negative x, and then y is equal to natural log u. Then in this case, u become a positive value. By using the chain rule, we will have dy over dx equals dy over du times du dx. For dy du, by using the first result, see it is 1 over u. Then du dx is equal to negative 1. We are going to substitute the expression of u back and put negative x here, then times negative 1. And negative become positive. The final result is 1 over x. By comparing these two cases, we know no matter x is positive or x is negative, the final result has the same form. Therefore, we can show the derivative with the same form, 1 over x, for x not equal to 0. This is how we obtain the second formula.